Hey guys, let's today do the two sum problem, and it's a very interesting problem because what happens is I guess the lead code 1. So these are the kind of problems which are pretty easy to, as they call as the low hanging fruits. So let's try to give it a shot today, and we should be able to do that. So let's see how we can fix it. What the problem says is given an array of integers, return indices of the two numbers such that they add up to a specific target. So it's asking us to give the indices of the two numbers, not the numbers themselves. So that's one good point to keep in your head. You may assume that each input would have exactly one solution, and you may not use the same element twice. So let's see what is going on here. Now, he gives an example where he says the nums is 2, 7, 11, 15, and target is 9, and the output in that case is a list of 0 and 1 because nums 0 is 2 and nums 1 is 7, and then you get 9. So that's where it is. So now let's start how we can do it. My approach is going to be that I will use a dictionary or hash map. And Python dictionaries are very strange, are very, I would say, very useful data structure, and you can use them for many different kind of problems. And usually, a dictionary would have a key value pairs, and the dictionaries and also the sets in Python are not supposed to maintain the order of insertion. So the order is not guaranteed. So these are unordered collections, basically dictionary, hash map, and sets in Python. And when we did the LRU cache problem using Python, what we did was that we actually use a ordered dictionary, which is a data structure that is actually provided by a package known as collection. So without that, the normal dictionaries, they do not maintain the order of the insertion. So let's start one of those normal dictionaries. So we can say map or dictionary, whatever you want. Let's say mapping equal to, start with the empty dictionary, and then we would walk the array that is given to us, nums. So usually, the way it works is you could use something known as enumerate. So enumerate, what it does is, so if you give it for I comma n in nums in enumerate, so enumerate would actually return a table with I um, with indices and the element themselves. So for I comma n in enumerate nums, what we can continue to do this is that if n in so what we can try to do that is that since the target is given to us, we keep track if the complement, because at any point we need to see if the target minus n, which is in the dictionary, because if target minus n is in the dictionary, then the sum of target minus n plus n would be equal to target, right? So basically we would be looking for target minus n. So we can say in mapping, if target minus n in mapping, then we can simply return the index of the return mapping. Let's see what we can return. We need to return a list, so we can say mapping. So now what did we have? So for each element in nums, we would be having key value pair. So the key would be the element in nums, and the value will be its index in nums. So, and we have to return the values. So we say if mapping, so then we need to return the n, the mapping for the target minus n, or the n, and comma, we could say mapping of basically the value for the target minus n in the hash map. So let's see. So return mapping n, or actually, you know what? We don't even have to do that, because see, we already know the mapping for n while we're walking. That's the I, right? So for so, or we might want to return in such a way that I is here. Let's see that. So if target minus n and mapping we return, else we can simply add the value of this element as a key in our dictionary, which is here named as mapping. So else map, and we will use this function on a set default. This is a pretty handy function. What it does is that if you don't have the mapping, the key in the dictionary, it would set the value, and it will not raise any kind of key error or anything. So otherwise we say n comma I, mapping set to default. So let's see. So now let's see if it basically works or not. So try to do a run code here. Let's see if it works. Okay, so it has been accepted. But what I'm wondering is that what happens that if we fall through this for loop and the target minus n is never found, so that means we would never return. So what would this function return? It would end up returning none, which is not a good thing, because remember the signature on line 2, which is by the way very Python 3 way of specifying the function signature, because in Python 3 you could do things like you could even have some kind of a advisory, or some kind of um, a way to tell the the person who is looking at this function signature what are these different arguments. For example, here is saying the nums is going to be a list of integers, the target is going to be an integers, and the return value going to be a list of integers. This is a very interesting thing, because before that, I guess in Python 2 you just have to rely on the documentation provided by the programmer. So that's interesting. So now you see that in this case, on line 2, it's actually supposed to return a list of integers. And what would happen in the way we have coded is that if the target is not found in if the target minus n is not found in the mapping, what we would return. Assume that we are given a case where there are no numbers, there are no two numbers in nums whose sum adds up to target, then that would not be a good thing. So I think for the sake of completeness, we are supposed to return an empty list here. So let's see now, let's try to do a run code on this one. Good, so that's working. Now let's try to submit. But submit, when you do a submit, it usually has more cases. So great, that's actually working. So we're doing better than 93% of Python 3 online submissions for two sum. So that was your lead code one, Python, using Python, solving the two sum problem. And in the future we'll probably take, as you say, this seems very interesting names here of the other next challenges. As you can see, three sum, four sum, and all that. So I don't know whether the naming has been deliberately, the name of the problem has been deliberately put that way, but it sounds definitely interesting. So we will just continue to take these problems in the future. But for now, adios. Have great time coding. Bye bye.